Hello geometry students, welcome to our next video titled Notes 4-5 Slope. A couple things, I'm going to try and do this all in one video, so it might be a little bit long, bear with me. Number two, make sure you fill out your WSQ when you are finished. Some students are not getting credit for the notes because they're not filling out the WSQ, so make sure you are watching the video, copying down the notes, and fill out the WSQ. Alright, slope is something you should remember from algebra. So we talk about a couple different ways in geometry and we use it quite a bit. First off, we want to talk about the purpose of slope. Why do we even have slope? Slope is used to find the direction of a line on the coordinate plane. Now it's very important that we know slope is always read left to right. So when you're reading slope, when you're looking at a graph, it's always read from the left side to the right side, just as if you were reading a book from left to right. So make sure you always do that. Alright, there are four different directions of slope. We can have a positive slope. From left to right, if we have a slope of a line or a line goes up, that's positive. From left to right, a negative slope looks like it's going down. And then a zero slope is when we have a line going straight left and right. We're going to call that a horizontal line. So if a line is horizontal, has a slope of 0. An undefined slope is a line going straight up and down, and we're going to consider that to be a vertical line. Alright, so make sure you know what lines look like, and you should be able to identify the slope just by looking at it. Alright, so ways we can find slope. There's one way to find slope. There's a formula. There's another way to find slope if you just look at the graph. So one way you might know is rise over run. If you've ever seen or heard slope called rise over run, that's if you count it on a graph. If you're counting a graph, you can go up and over, go the rise over run. Well, that's equal to this formula here. This is the slope formula. y2 minus y1 over x2 minus x1. And again, the 2's and the 1's just mean like the second y coordinate and the first y coordinate, the second y coordinate, or second x coordinate, and first x coordinate. Another way you might see slope written on a page or in a book, something is delta y over delta x. And this delta is a Greek symbol. It's a triangle, yes, and it means delta. And that's like saying the change in y over the change in x. Okay, so delta y means the change in y, and delta x means the change in x. Delta means change in math. So if you see it, don't be confused. Alright, so on a graph, if we have a line, the rise is vertical and the run is horizontal. Okay, and then this line right here is a positive slope. If we had a negative slope, the rise would be negative, but the run is always positive. Okay, so this rise number can be positive or negative. The run number will always be positive. We'll see that. All right, let's do a couple examples. Our directions on our examples, make sure you write this down. Find the slope of each line, and then identify whether the slope is a positive slope, a negative slope, 0, or undefined. All right, if I have two coordinates, the easiest thing to do is going to be to use my slope formula. So my slope formula, let's remember what that is. It's y2 minus y1 over x2 minus x1. All right, and I can take a look at my example here, and let's denote what we have. This is my x1, y1. This is my x2 and y2. It always helps to label those. So I see I subtract my y's. I've got 4 minus a negative 2 over, subtract my x's, 3 minus a negative 3. Alright, so 4 minus negative 2 is like 4 plus 2, that's 6. And 3 minus a negative 3 is like 3 plus 3, that's also 6. Reduce at all possible. 6 over 6 is like 1 over 1, and I can reduce that down to just a slope of 1. That's a positive number, so easily seen as a positive slope. Alright, next example I have is a graph. And on a graph, you can use my slope formula. That's always doable. I gotta know what the coordinates are. Or I can count it. I can use my rise over run. Alright, so using rise over run, always left to right. I start at the leftmost point, and I said I gotta go down 1, 2, 3, 4. Then I gotta go to the right, 1, 2. So going down is a negative number, that's negative 4. Going to the right is a positive number, that's positive 2. So writing out my slope, I've got negative 4 over 2. Simplifies down to negative 2 over 1. And I can go down to negative 2, but negative 2 over 1 is just fine. It's at a negative number, and I see from my line there that it's a negative slope. All right, example C, I've got two coordinates again. So I've got my x1, y1, I've got x2, y2. So subtract the y's, I've got -2 minus a -1 over, I've got 2 minus 2. All right, -2 minus a -1 is like -2 plus 1, that's -1. And then a 2 minus 2 is 0. Now notice, if we need to find the slope of this, can we divide -1 divided by 0? Let's go to a calculator. On my calculator, if I have a -1 and I divide it by 0, what does it say? You cannot divide by 0. So if I can't divide by 0, that's as if it's undefined. I'm going to give myself more room here. Okay, so when it's got 0 on the bottom, that is an undefined slope. All right, and we can see if we would graph this out, it would be a straight up and down line because the x coordinates are the exact same of 2. So that's just a slope of undefined. There is no slope. Look at example D. You'll notice quickly it's a horizontal line. All right, and on my graph, I can count it, rise over run. Well, I don't rise at all. From left to right, I stay the same. So my rise is 0, and then my run is to the right, 1, 2, 3, 4, 5. Well, 0 over 5, what will that give us? Let's check our calculator. If I have 0 and I divide it by 5, I end up with 0. Anything with 0 on the top gets me a value of 0. So 0 over 5 is a slope of 0. That is my slope, and again, a 0 slope. Ooh, cool, black and white. One more thing, if I've got parallel and perpendicular lines, here's the extra thing, okay? In geometry, we talk so much about parallel and perpendicular lines. It's quite easy that if I have two lines that are parallel, you'll know they'll never intersect. So what do you think happens with their slopes? What do you think their slopes of parallel lines are? Well, the slopes of parallel lines are equal. Or we could say they're the exact same. So if one line has a slope of 3, the parallel line to that has a slope of 3. All right, perpendicular lines, if I've got two lines that are perpendicular, it means they cross at a right angle. Their slopes are negative reciprocals. Reciprocals. R-E-C-I-P-R-O-C-A-L-S. All right, negative reciprocals. Well, example of that, and in other words, you may have heard this before, we can take the number and flip and switch it. Flip and switch. So for example, if I have a slope of 2/3, if I flip the fraction and switch the sign, that's the negative reciprocal. So the negative reciprocal of 2/3 would be -3 over 2. All right, you do one. What if I have -3? What's the negative reciprocal of -3? Well, I got to flip the fraction here. Well, what's the fraction? Underneath of this 3 is like there's a 1. All right, so if I flip the fraction, it becomes 1/3, and then change the sign. It was negative, so now it becomes positive. One more. If I have a slope of 0, what is a negative reciprocal of 0? Well, that would be if 0 is on the top. So 0 becomes on the bottom, then we can't do that. So that's undefined. Okay, so if I have a slope, if I have a line with a slope of 0 and a line with a slope of undefined, those two lines are perpendicular to each other, obviously, because one's horizontal and one's vertical. All right, bring all that stuff tomorrow. We'll be spending a couple days on slope.